Now we can write the report. Which I've actually already written. Okay. The reporting guide provided to you for ANOVA will apply to MANOVA as well. It shows the order in which you are expected to report the results for this course. But for now, I'll show you an alternative way of reporting using both text and tables to simplify the results. When reporting the results, it is best to start your report with a description of the analysis as well as the specific variables that the analysis is intended to address. In this case, I mentioned here that multivariate analysis of variance was used to test the effect of maternal parenting style with moral reasoning and pro-social behavior among adolescents. I also indicated the alpha value of 0.05. And this statement here alerts the readers that although 0.05 is the standard, there will be an instance when it is adjusted. Okay? So alpha is set at 0.05 unless indicated otherwise. And this is a good way to report the descriptive statistics. So instead of writing it in textual form, a table form allows the readers to see the values at a glance without having to go through a long text, because sometimes reporting these numbers, these figures in text can be confusing. So these values here actually came from our estimates. Okay? So you can report using the table, the values from the descriptive statistics. But because I also want to report the 95 confidence interval, I use the estimated marginal means. The value of the means will still be the same, but instead of the standard deviation, we are reporting the standard error. And then we have the 95% confidence interval with its lower bound and upper bound. Note that the symbol for the mean and standard error are italicized. So after reporting the descriptive statistics, we move to the assumptions for MANOVA. Okay. Scatter plot matrices. Okay. So this is our scatter plot matrices. I copy-pasted this one into appendix for the readers to examine. So scatter plot matrices indicate that the two dependent variables have linear relationship in all levels of parenting styles. Bivariate correlation, as we saw in our correlations results. Using Pearson's R, reveal that moral reasoning, and then we report the means and standard deviation, as we can see from this table here, are statistically significantly correlated. So you have your R value, R symbol, which represents the Pearson's R coefficient, and then this is our degree of freedom. Although you wouldn't see it here from the correlations table, essentially this is computed by subtracting the number of variables to the sample size. So our sample size is 90, and we have two variables being correlated here, which is moral reasoning and pro-social behavior. That's why we have a DF of 88. Okay, and then this is our Pearson correlation, 0.785. We rounded it up to 2 decimal places. And remember, there is no leading zero because the R coefficient cannot exceed 1. Okay? And we have our p-value because it's 0.000. We report it here as less than 0.001. Otherwise, we would have an equal sign here and then the actual value that is reported here. Okay. And then you can also add an interpretation of that correlation. So we have the valence or the sign, whether positive or negative, or rather the direction of the relationship, and the interpretation of that direction. Okay, in this case, higher moral reasoning is associated with higher pro-social behavior. And then we proceed with the next assumption, which is multivariate normality. However, because we cannot test this in SPSS, we report univariate normality instead. Okay, so let's go to our results here for normality. Okay. So we have here our normality table. Okay. Remember that because there are so many values for the Shapiro-Wilk test, I opted to report this in table form. Okay. Shapiro-Wilk test results shown in table 1, or not table 1, this should have been table 2, indicate that moral reasoning was normally distributed, okay, and so on. So notice that in the text, there's no more numbers. So all the numbers are in table, but the interpretation of what those numbers mean are written in text. Okay. And then we proceed with the assumption of variances, homogeneity of variances, and covariances, okay, or also known as homogeneity or equality of covariance matrices. Okay. And that is shown from this table, on this table I mean. So Box's test of equality of covariance matrices show that the variances and covariances were not homogeneous. And then you have your numerical results here. So we have the degrees of freedom, which is from DF1 and then DF2. And then you have the F statistic, which is this one here. And then the p-value, which is represented by the SIG here. Okay. And then I explained briefly that because sample sizes were equal, that this should not be a big issue. Nevertheless, to address both violations of normality and homogeneity of variances and covariances, Pillai's trace, which is deemed as a robust statistic for multivariate effect. So see, because I'm making a claim about the robustness of the statistic, I cited field here to support my claim. Okay. And so we proceed with the multivariate effect. You have to indicate what statistic is being used. Okay. So in this case, we're using Pillai's trace. Okay. And we indicate the value the symbol for realized trace is this V. And then you again have the F statistic, the P value, and then the effect size in terms of partial eta squared. Okay, so remember that the notations should be italicized. And notice that the partial eta squared here doesn't have a leading zero. This is because for single factor designs, in this case, we only have one independent variable, which is parenting style. So for single factor ANOVAs, the value of partial eta squared will not exceed 1. But for factorial designs, the value of partial eta squared can exceed 1. And so, for factorial design, there should be a leading zero here. Okay. And then I have a statement here to say that this result provides support for the research hypothesis. And then we proceed with reporting the findings from the univariate tests. So this would be the same as reporting ANOVA, a regular ANOVA. But before I proceed, I remind the readers that the alpha value was adjusted to 0.025 following the Bonferroni method to reduce the risk of type 1 error. And then you proceed with test reporting the result of the assumption of homogeneity of variances. Remember that this Levene's test here that we see is for the univariate statistic. That's why we're reporting it here when we report the univariate result. Okay. And just like in a regular ANOVA, we have the Levene's test F and the corresponding p-value. And we have to do that for both of the dependent variables. So we have prosocial behavior and moral reasoning. So notice that it was met for prosocial behavior, but not for moral reasoning. And so that means that we need to choose the proper post hoc test or report the correct post hoc test depending on this violation of the assumption. Okay. And so we have here the result of the univariate test. So remember, this line, statistically significant, should be indicated, and then you have your F value, the P value, and then the partial eta squared. And again, this doesn't have a leading zero because it cannot exceed 1, at least for a single factor design. Okay. And then because the post hoc test has a lot of values to report, again, I report this in a table form. Okay, so post hoc analysis, see table 3, showed that adolescents with authoritative mothers had higher level of moral reasoning than those with authoritarian and permissive parents. So again, when the results are reported in table form, you do not have to write the numbers in text. You just need to report the interpretation. Okay. And then overall, results suggest that authoritative parenting style, which is characterized by a balance between warmth and control, is associated with more internalized moral reasoning and higher tendency to act pro-socially towards peers. So that's it. That's the end of the lecture. If you have any questions, kindly post your questions on the forum. Till next time, bye!